Two different ways to prove triangles congruent. I've asked you this many, many times. What was the first way we learned to prove triangles congruent? Side, side, side. Okay? And what was the second way? Side, angle, side. And these were what types of things? These were they theorems, postulates, what are they? These were postulates. And what do we know about postulates? They're just, right, you don't prove postulates, right? You just accept them as fact, okay? So these are postulates. The next ones we're going to do are theorems. Actually, I lied a little bit. The first one we're going to do is another postulate, okay? So, and then the next one we're going to do is a theorem. So we start with the theorems. I thought the next one was... Well, anyway, here we go. The next one, very similar to this, is called angle, side, angle. So if you think about this, it's just the same process. It's not really any different, okay? What we're doing here is the same thing, except you just have to show some different information that we showed earlier. So I tell you what, I'm not even going to put letters on here. Let's just do this. What if I knew that this side was equal to this side? Let's say this angle is equal to this angle here, and this angle down here, the bottom left, was equal to this one right here. According to this postulate, what's true about those triangles? They're congruent to each other. That's the only difference. All right, it's just like this, isn't it? It's really no different. But what has to be true about that side? Is it just any old side? It has to be the side that's what? Yeah, let's not say in between. Let's use a word, and I've tried to throw this in there. No, it's that. The included. Thank you very much. Somebody was listening. It's the included side. All right, I've got two angles and the included side. That's how they refer to it in the book. Everybody understand that? When I say the included side, it's between the two angles that are given equal to each other. It's not this angle, and this side. But you're going to see something in just a minute here. All right, so this is angle, side, angle. You with me? That's a postulate. There's really no proof on this. All right, that was pretty easy, wasn't it? Let's do a different triangle just for the sake of variety here. Let's pull this down here. And then let's put this one right here. Now watch the information that we're going to give here. I'm going to get this angle is equal to this one. And I'll kind of show you why this one is a theorem and not a postulate. Let's say this angle right here is equal to this one right here, and they give you that this side is equal to this side. Now, it's definitely not side, 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 right? Because there's only one pair of sides. What is it? Side, angle, side? No, because again, I need two sides, don't I? Is this angle, side, angle? Is the reason that these are congruent angle, side, angle? No, because this is angle, angle. This side is what? It's not. What's the word? It's not included. It's not in between these two. If it was between these, if it was angle, side, angle, it would be this side and this side would be equal to each other. Do you see that? So they call it angle, angle, side. Now why is this a theorem and not just a postulate? Because we can actually prove it. Let's just go through a little sketchy kind of proof. I'm not going to get real detailed on it. But what do we know? I know two angles equal to two angles, correct? So what do we know already? We talked about this yesterday, I believe. If I know two angles equal to two angles, what must be true? The third angle must be equal. That's exactly right. And what's the reason for that? Just say it. Third angle theorem. It's a third angle theorem. That's what we're going to call it. All right. Different books might call it different things, but our book will call it third angle theorem. So watch. If I know these two angles are equal to each other, I could say that the third angles are equal because of the third angle theorem. Would you agree? Now let's take a look. Now from one of these, can I use one of these postulates now to prove that these two triangles are congruent? Yeah. What can I use? Side, angle, side? Angle, side, angle. Right. Okay. Now I could go angle, side, angle. Correct. Now, do I have to go through that though? Do I have to show that that third angle is equal and then go angle, side, angle? No, I could just do what? I could just say right off the bat, without even showing that third angle, I could just say, okay, these triangles are congruent to each other because if I have two angles and a non-included side, guess what I can still say about these triangles? I can say they're congruent. And what would be my reason for this? Angle, angle, side. If you really, really wanted to, you could go with that third angle, right? You could say, okay, this angle, this third angle is equal to this third angle because of the third angle theorem. Then they're congruent because of angle side angle. But this saves you a step, doesn't it? It saves you that step of saying that those third angles are congruent. Actually saves you 2 steps. You with me on that? Okay, that's why it's a theorem. Do you understand why it's a theorem now? Because we took the postulates that we've already learned and we applied them, and we said that these two things are congruent because of angle side angle. But then you looked at it and you're like, well, wait a minute, I don't have to go through that. I don't have to say that this angle is equal to this and it's congruent because of angle side angle. I could just say this. I could shorten it up and say, okay, if I have 2 angles and a non-included side, then the 2 triangles are already congruent to each other. I can save myself a couple steps. So that's a reason right there. Angle, angle, side. Okay? All right. Hang on just a sec. All right, here we go. Here's our situation. It's another proof. So first thing we're going to do is we're going to mark this stuff. I'll mark this in a different color. It says CB bisects angle ABD, line segment CB, bisects angle ABD. Let's find ABD. ABD is this big angle right here, this big angle B. Well, that line, the diagonal line right there, bisects it. So what do we know about bisecting an angle? What does that do? Yeah, let's not say cut it in half, okay? I don't know if you remember, but when I first talked about bisecting, it's really not the definition that it cuts it in half. What does it do? It cuts it into 2 equal parts. Exactly right. That's what I want to think of when I think of definition. You're probably saying, well, that's what it means if you cut it in half. Okay, but technically for this proof, it's a lot better to think of it, it cuts it into 2 equal parts. So what must be true about these 2 angles right here? They got to be equal to each other. Why? Why are they equal? Because it's not given that they're equal to each other. It's given that this is being bisected. So, what do you think? Definition of bisector, right? Angle bisector, we'll call it, okay? So the reason that this angle right here is equal to this little angle right here is because the definition of angle bisector. Does that make sense? So if it says that you've bisected it, and you're like, okay, if it bisects it, then that and that are equal. Well, where did you get that from? You got it because the definition of bisector tells you, right, that if you bisect it, you split it into 2 equal parts. In this case, it's angles, right? So 2 equal angles. It also bisects angle ACD. ACD. So I could say that this angle is equal to this angle right here. Are you kidding me? Why would they give you this? I thought they were going to give you something different. Sorry about that. I thought they were going to give you yeah, I thought they were going to use one of the ones that they taught in this lesson. That's kind of weird. You'd think they would do that. But anyway, I just noticed it. We'll do this anyway. That's all they give you right there, isn't it? All right, so we want to prove that this triangle right here, this top triangle, this bottom triangle, are congruent to each other. You can see it right now. Dean, what is it? What's the next step? Third angle. Do you want to go third angle? Why do you want to go third angle? 3 angles make it congruent? Do we have an angle, angle, angle theorem? No, there is no such thing. Reflexive, that's right, it's reflexive. Travis, I knew you'd know it, I'm giving somebody else a chance. Alright, so here we go. So the reflexive, right, BC equals BC. Everybody see that? It's equal in both of these. If it's shared by both of them, always look to see if you're going to use it, and reflexive is always a nice one. Don't we like reflexive? Yeah, okay, that's always a nice one. Now, why are these triangles congruent? That's enough right there. What? Angle, side, angle. That's right, angle, side, angle. Now, if you really, really wanted to, this would be an extra step. I wouldn't do it this way, but if you wanted to, Dean, you said A and D would equal each other. You could do that and then say angle, angle, side. But why do that? Would you agree? If you wanted to, you could and say they're congruent because of angle, angle, side. But that's... Yeah, I don't think they're going to ask you that, but they just want you to prove that they're congruent to each other. All right, does that make sense? It's not hard. These proofs are pretty easy, aren't they? Yeah, I think they are. Okay, all you had to do is look for one thing. Look for that side, and we've talked about that a lot. We said reflexive property. Then you look at the triangles, and you're like, oh, I got an angle, got a side, got an angle. I'm not going to write all the stuff down. I just went through it. All right, you can write that down on your own if you want to. Let's do another one. All right, sorry, I forgot to record this. Anyway, all I've done is just mark the stuff, all right? I marked the 2 angles, the 2 sides. I marked these 2 angles because it says JL bisects angle KLM. All right, we good with that? All right, so now let's take a look at it. What about the information that we have right now?
Well, if JL bisects KLM, isn't KL and ML equal?
KL what? KLM? Is it? What'd you say?
You're trying
KL?
to prove that KL is equal to ML? It already
That proves that KL and LM. What's my reason?
Because the JL is bisecting KLM.
And that makes this. Let me show you again. Hate to do this, but watch. Okay. Actually, let's do this. Oops, that's not what I wanted. Do you need to go JL equals JL though? Yeah, but do you need it? I mean, you can. So it wouldn't be wrong, but do you need to? Watch this. Watch this. I think, Chandler, I think I know what you're asking. If you're saying if this angle and this angle are equal to each other, right?
No, like
Then this side and this side. You said right. You said JL bisects this angle, right? I know. That's what I'm saying. So this, you're saying then that this angle equals this angle, right? Because it bisects it. But you're also saying that this side equals this side right here. Is that what you're saying? Let's do this. Oops. Let me ungroup that thing. Okay. But what if we did this? Okay. And let me see if this helps out. Look, this angle is still equal to this angle. I didn't change that angle at all. Does that make... Does that... Yeah, but you said if this... Oh, I see what you're saying. You're saying if it bisects it.
Yeah, I said if.
Okay.
Since it's bisecting.
No, it's bisecting it. It's still bisecting it because look, this angle is still equal to this angle. So this still bisects this angle right here. So you're telling me if it bisects the angle, then this side and this side would be equal to each other. Is that necessarily true? It bisects the angle. It bisects angle KLM. Look, angle. It doesn't bisect the line segment. Okay, it's not a midpoint. So anyway, I just showed it to you. You need to believe me on that one. Okay? So I know, thank you. So let's take a look. Look at these two triangles. Now I'm trying to prove that KL and LM are equal to each other. But before I do that, we talked about this yesterday. We talked a little bit about it, quite a bit about it. If this, talk about the triangles. Even though it doesn't say prove the triangles congruent to each other, what do you think must be true about these two triangles with this information, Travis? They're congruent. Give me a reason why these two triangles are congruent. Angle, angle, side. That's right. Do I have to go JL equals JL? I don't have to, do I? Okay, that's not going to help me at all, really. I've already got two angles and a non-included side. So why are these two triangles congruent to each other? Because of angle, angle, side. Now, who cares? I didn't ask you to prove the triangle's congruent, did I? I said to prove that KL is equal to LM. Well, it actually helps knowing that the triangles are congruent. If the triangles are now congruent to each other, what must be true about the corresponding parts? Huge hint. That's right, the corresponding parts must be congruent. So this side must be what? Equal or congruent to this side because of corresponding parts of congruent triangles are congruent. Or, what do we write? CPCTC. Alright, so watch what I've done. I proved the triangle's congruent. Even though it didn't tell me to prove the triangle's congruent, I proved the triangle's congruent. Because what does that do to all the other parts? If these two triangles are congruent, then all the other parts that match up must be equal to each other as well. Would you agree? So, that's really the only thing you could have proven because the triangle's congruent. Because I could have already said that these angles were equal. Now, I could say they're, once I prove the triangle's congruent, I could say this angle and this angle are equal because of corresponding parts, right? But I could have already said that they were equal to each other because of what? If two angles equal two angles, then what? The third angles are congruent as well. So I could have just said because of the third angle theorem to begin with, couldn't I? All right. I could have said JL is equal to JL because of reflexive property, right? So I could have said that this was equal to this one right here before I even proved the triangle's congruent. I could have said JL is equal to JL before I even proved the triangle's congruent. The only one that I could not have said were equal to each other was KL and ML. There's no way I could have said they were equal to each other unless I did what? Prove the triangles congruent. So now that the triangles are congruent, now I can say KL is equal to ML because of corresponding parts, CPCTC. Does that make sense? Okay. Do those problems from last night now. I gave you some explanations of this, so you should be able to get them right tonight. So get them right tonight and turn them in tomorrow.